Central Siberia, the last days of June 1908. North of a small trading post called Vanavara, the taiga runs unbroken toward the Arctic, larch and pine over peat bog, rivers that stay frozen more than half the year. The nearest railway is weeks away by horse and river barge. No road has ever been cut through this country. The people who know it are Evenki, reindeer herders who move camp with the seasons, a few families to a valley. On the morning of June the 30th, a little after 7 o'clock, the sky over the Podkamenia Tunguska River is clear and pale. In the camps along the Chamba and the Avarkita, families are still asleep beside their hearths. And at Vanavara, 65 kilometers south of a stretch of forest that no map had ever needed to name, a farmer called Semenov sits on the porch of the trading post facing north. June the 30th, 1908 is the date of the Tunguska event, the largest cosmic impact in recorded human history. It happened over one of the emptiest regions on Earth, and for nearly 20 years, almost nobody outside that region understood what it was. This is the story of the event, the land that hid it, and the people who saw it. What Semenov later described to the scientist who finally came to ask was fire in the northern sky, a light so hot on his skin that his shirt felt as if it were burning. Then the ground jumped, and something threw him from the porch. He was 65 kilometers from the point directly beneath the blast. Across a region the size of a European country, people saw a column of light climb over the forest, and then heard thunder out of a cloudless sky. Repeated blows, like artillery, that kept coming after the light had gone. Villagers along the Angara River, 200 kilometers away and more, were knocked off their feet. Windows broke. Near Kansk, 600 kilometers away, newspaper accounts describe a driver on the Trans-Siberian Railway stopping his train, convinced something aboard had exploded. The planet's instruments caught what no witness could measure. A seismograph station at Irkutsk, 1,000 kilometers south, registered the ground wave. Barographs across Europe, including stations in Britain, recorded a pressure wave in the atmosphere that had traveled around the world. And for several nights afterward, from Western Russia to Scotland, the night sky glowed. There are accounts from London of people reading newspapers outdoors at midnight by a strange silvery light. Dust and ice, thrown to the top of the atmosphere over Siberia, was scattering sunlight around the curve of the Earth. Nobody knew that yet. That is the problem this morning handed the world. The energy released over the Tunguska basin was somewhere between 3 and 15 megatons of TNT. The bomb that destroyed Hiroshima carried roughly 1,000th of the upper end of that range, and Hiroshima was still 37 years away. In 1908, the largest explosions human beings had ever produced were measured in tons. Witnesses reached for the biggest comparisons they had: artillery, thunder, the end of the world. Scientists in Europe filed the barograph traces as an atmospheric curiosity. There was no category yet for what had actually happened. To understand why the answer took 19 years, you have to understand where this happened. The Podkamenia Tunguska drains a stretch of the central Siberian plateau where winter lasts 8 months and the ground below the surface never thaws. In summer, the land turns to bog. Travel means rivers or nothing. In 1908, there were no roads here, no telegraph north of the trading posts, and a scattered population, Evenki camps, and a handful of Russian settlements, spread across an area larger than most European countries. Vanavara, the nearest outpost to the blast, was a few wooden buildings above the river. Irkutsk newspapers reported a meteorite within days. The director of the Irkutsk Observatory collected witness letters from across the region, and then, for years, nothing followed. Reaching the site meant months of travel toward a point nobody could fix on a map, in country that swallowed expeditions whole. Then history closed the door entirely. World War in 1914, Revolution in 1917, Civil War after that. Russia had no attention to spare for a fallen star in the taiga. The man who finally went was Leonid Kulik, a mineralogist at the Academy of Sciences and the country's leading student of meteorites. In 1921, he came across the old newspaper reports and traveled the Trans-Siberian collecting testimony. Every account pointed the same direction, north of Vanavara. It took 6 more years to mount a real expedition. In the spring of 1927, Kulik went in, by rail, by horse-drawn sledge, and then up the frozen rivers with Evenki guides, into country no scientist had ever surveyed. What he saw from the first ridge stopped him. Leveled forest to the horizon, every trunk down and every trunk pointing the same way. As he moved, the direction of the fallen trees turned with him, like iron filings around a magnet, all of them pointing away from a single center. The fall zone covered more than 2,000 square kilometers, tens of millions of trees. At the center itself, he found the strangest evidence of all: trees still standing upright, stripped of every branch, a dead forest of telegraph poles. And the one thing he had come for was missing: no crater. Kulik was a meteorite specialist. In his experience, things that fall from the sky make holes in the ground, and a fall this size should have made the largest hole in modern history. He spent that expedition, and 2 more over the next 3 years, digging in the peat bogs for a buried iron body. He never found it. In 1938, he arranged an aerial photographic survey that captured the fall pattern from above, a great butterfly shape spread across 250 square kilometers of camera coverage. Here is the other half of what the remoteness did. For those 19 years, nothing touched the evidence. Nobody logged the fallen timber, nobody cleared it, salvaged it, or built over it. The trees lay exactly where the blast had put them, a vector map of the explosion drawn in fallen trunks, still readable decades later. Researchers were still measuring the fall directions in the 1960s, tree by tree, and reconstructing the shape of the blast from them. In almost any settled place on Earth, that record would have been erased within a season. Here, the same emptiness that kept science away for 2 decades kept the evidence intact for it. The record outlasted its keepers. Kulik died in 1942, a prisoner of the war that had once again shoved Tunguska aside. In 1975, most of the original negatives from his aerial survey, some 1,500 nitrate plates, were deliberately burned as a fire hazard. What survives in quantity is the ground photography from 1927 to 1930, the fallen forest, radial and silent. Nearly every image of that forest in this episode comes from those expeditions. The blast pattern itself, photographed 19 years after the morning that drew it. The first people to see the Tunguska explosion were not scientists, and the first record of it was not written by any instrument. It was carried in memory in Evenki families for 18 years before anyone wrote it down. The Evenki are the indigenous people of this taiga, reindeer herders and hunters whose camps, in June 1908, stood within 30 and 40 kilometers of the point beneath the blast. They were the closest human beings to it, by a very long way. In 1926, a Soviet ethnographer named Innokenty Suslov attended a Muniak, an Evenki Congress, and interviewed around 60 people who had lived through that morning. He recorded where each family's chum, their tent, had stood, close enough that the positions can still be plotted on a map today. He also recorded that asking was not simple. The land where it happened was under religious prohibition, and the subject itself was bound by taboo. He had to come at it sideways by asking who among them had suffered losses. What they told him is specific. A woman named Akulina camped about 30 kilometers out, her tent torn off its poles and carried away, herself thrown through the air, the forest burning around her, and the family's reindeer scattered into the smoke. Many of the animals were never found. The brothers Chuchansha and Chikaran of the Shanyagir clan on the Avarkita River, woken by a shove in the dark of the tent, a whistling, then a hard wind. Chikaran said at first it sounded like a great flock of waterfowl going over. Then came the blows, 5 of them, by Chuchansha's count. One threw him into the coals of the hearth. An old man named Alkiko described his father Lurbaman, collapsing that same day and dying. He was buried by evening, according to their belief. In all, the accounts gathered at the Congress named 3 dead: Lurbaman, Ivan Machakugir, who was injured and did not recover, and a shaman named Uiban. Storage platforms burned with the winter food still in them. One family's bag of flour was found fused into a black crust. The Evenki also told Suslov what the morning meant. The catastrophe, many said, was the revenge of a shaman named Magankan, carried out by Agdi, iron birds of thunder. An elder said he had seen the birds himself, heard them rattle and strike. The shamans declared the land where they struck closed, and Evenki guides were unwilling, at first, to lead Kulik into it the following year. It is worth being precise about what this record is. These accounts were collected 18 years after the event, in Russian, through a Soviet ethnographer, and translated since. Nobody should read them as verbatim transcripts of 1908, but as a body of testimony they hold together. The camps can be placed, the details repeat across independent tellings, the shove before the sound, the wind, the multiple blows, the fires. All of it matches what the instruments wrote down 1,000 kilometers away. Suslov saw no point in arguing with the Agdi, and there is none. Seen from a reindeer camp beneath it, a megaton airburst was a flock of iron thunderbirds, in the same way that, to a physicist in London, it was an unexplained wobble of ink on a barograph drum. It was the same morning, described with the instruments people had. So what does the evidence actually support? The scientific consensus, and it is an unusually strong one, is this. On June 30th, 1908, a natural object from space, most likely a stony asteroid on the order of 50 to 100 meters across, entered the atmosphere over Siberia at tens of kilometers per second. Air resistance at that speed acts like a wall. The object crushed itself against its own shock wave and came apart, 5 to 10 kilometers above the ground, releasing its energy in seconds as heat and blast. An airburst. That single mechanism accounts for the whole pattern on the ground. A blast wave arriving from above pushes trees outward in every direction from the point beneath the explosion, the radial fall Kulik mapped. Directly underneath, the force comes straight down, so the trees at the center stay standing, while their branches are stripped. The telegraph pole forest. The fireball's heat scorches the forest without cratering it, because the object is destroyed in the air. No crater and no iron body in the bogs, no matter how many years Kulik dug. In 1993, Christopher Chaiba and colleagues showed in the journal Nature that a stony asteroid of this size naturally fails at exactly this altitude. In 2007, supercomputer modeling at Sandia National Laboratories reproduced the Tunguska tree fall with a downward flowing airburst and found the job takes as little as 3 to 5 megatons. And in 2013, the world watched the same physics on camera when a 20-meter asteroid burst over Chelyabinsk with about half a megaton. The same flash, then the same delayed hammer of a shockwave, this time over a modern city full of cameras. Anyone can now watch the physics that leveled the Tunguska forest on video from a dozen angles. What about the other explanations this event has attracted? In 1965, 3 physicists, including a Nobel laureate, proposed the object was antimatter annihilating in the atmosphere. That idea made a testable prediction. Annihilation radiation should have created a spike of radioactive carbon in the world's trees in 1909. Careful measurements, including of trees near the blast, found no such spike. The hypothesis failed its own test. In 1973, 2 physicists proposed a microscopic black hole had passed through the Earth. That also made a prediction. A black hole does not stop, so it would have exited through the North Atlantic minutes later, producing a second atmospheric blast. The world's barograph records from that day show one event, over Siberia, and no exit. It also leaves the glowing night skies unexplained because a black hole deposits no dust. That hypothesis failed too. And the crashed alien spacecraft? That one has a birthday. It comes from a short story published in 1946 by the Soviet science fiction writer Alexander Kazantsev, written in the shadow of Hiroshima, imagining a nuclear-powered ship exploding over the taiga. It was fiction, labeled as fiction, and it migrated into rumor. A century of expeditions has never recovered wreckage of any kind. Each of these theories dies on a specific measurement: a carbon spike that is not there, an exit blast that is not there, wreckage that is not there. The airburst explanation is the one that predicted what is there. This channel usually ends with a case held open. Tunguska does not need one. The verdict here is plain. The Tunguska event was the airburst of a natural cosmic object, an asteroid or perhaps a fragment of a comet, and the evidence for that is about as strong as evidence for a century-old event gets. The treefall pattern, the seismic and barograph records, the modern simulations, and a filmed analog over Chelyabinsk all describe the same physics. What remains genuinely open is narrower and worth stating exactly what the object was made of and precisely how large it was. No confirmed fragment has ever been recovered, and until one is, rock or ice stays an honest argument, which leaves the part of this story that instruments never measured. In 1908, something happened that nobody on Earth had a framework for. The Evenki closest to it understood it through the sky world they knew. Iron birds of thunder sent in anger, and land that must be left closed. European science further away understood it through the falls it knew, a meteorite, therefore a crater, and Kulik dug for a body that was never there. Both were wrong in the details and rigorous within what they knew, and both kept the record that eventually let someone else be right. The explosion took seconds. The explanation took most of a century. The gap between them is the time it took people to build a framework for something the world had never shown them before. This channel tells the stories at the edge of the map, where the records run out and people had to make sense of things anyway. If that is the kind of history you want more of, subscribing is the best way to see the next one. Thank you for watching.